Alright, so welcome back for one more time. My name remains the same, McAfee, and then this is Coffee Class. In Coffee Class, we just take time to take you through some concepts in mathematics, both core and then elective mathematics. We are hoping to add a bit of history in some weeks to come. So just help us so that we can be able to reach the numbers, get to other people so that at least our content will go far. And then if it goes far, we'll be able to do more from the motivation that you would give to us. All right. So elective mathematics, the questions just happen to be on the board. Given that log a base 2 is equal to 3, log b base 2 is equal to negative 2, and log c base 2 is equal to 5, you are to evaluate log 8 base 2 times a power square root of a power 5b all over c. There are two ways to go about this question. I'll try and give you all the ways that I know to go about the question, so that when you get stuck at one place, you can be able to use the other way or the other method. Okay, so over here, either we find the values of a, b, and then c, like I just started before shooting the video itself. So log a base 2 is equal to 3. It's the same as having the a standing alone, and then the 2 will be raised to the power the result on the right hand side, or the number standing alone here. The same thing, b is equal to 2 to the power negative 2, c is equal to 2 to the power 5, because that is what was given in the question. So I do substitution. I substitute a, b, and then c into the main question. So I now have log 8 base 2. I know the value of a to be 2 power 3. But remember, the a itself is being raised to the power 5. And then I know the value of b as 2 power negative 2 all over 2 power 5, like this. Yes, 2 power 5, sorry. Now I can continue and then try simplify from indices. Since the bases are the same, we can do something about the powers. This from the law of powers says that we should multiply the powers. So by multiplication, 3 times 5, which is 15, 2 power 15, times 2 to the power negative 2 all over 2 power 5. I have this. And then also from indices again, since the bases are the same, we can now add the powers and they are multiplying. Add the powers. So I get root of 2 power 15 minus 2 over 2 power 5. Okay. So I continue from here because I'm trying to be chiseled with my board. This question is going to take a lot, so I'm trying to manage the board. This would be log 8 base 2 square root of 2 power 13 minus 5. This would also go up, making it minus 5. So root of 2 power 8. I know square root is the same as a number raised to the power 1 over 2. So 2 exponent 8 all raised to the power half. This will give us 2 exponent 4, like this. Okay. I know this is the same as log 2 to the power 3 base 2, because I can change this to 2, the base here, plus log 2 to the power 4 base 2. Remember from logarithm, we were told that if you have a multiplication like this, you can expand it to be addition. That is why when you have addition, you can just put all together, then you get a multiplication. So that is the same concept or the rule I'm applying over here. Nothing different. Okay. So I have log 2 to the power 3 base 2 plus log 2 to the power 4 base 2. I can bring the powers before the log. If I do so, I get 3 log 2 base 2 plus 4 log 2 base 2. Log 2 base 2 is equal to 1. Any log of a number to the same base is 1. So 3, 1, 4, 1. I get 7. The alternative method is that you try and get your log a base 2 in the question, and then that's all. So remember I told you from here that when you have the square root, it's the same as power 1 over 2. So the same thing. And then remember the power is going to affect everything in the brackets there. And then since the C is dividing, we can subtract it. So that I have something like this. This is base 2. And now remember this side 2 is multiplication. This side is multiplication. So I can now add those places too. So I have log 8 base 2 plus log a power 5 over 2 base 2 plus log b power 1 over 2 base 2 minus log c power half base 2. All of them base 2, base 2, base 2, base 2, base 2. I can bring the powers in front now, so that I have here to be log. This is going to be 2 to the power 3 base 2 plus, I said I'm bringing the power, so 5 over 2 log a base 2 plus 1 over 2 log b base 2 minus 1 over 2 log c base 2. I know log a base 2, I know log b base 2, I know log c base 2. All I need to do now is to substitute. So in place of log a base 2, I put my 3 from the question. In place of b base 2, I put my negative 2. And then finally, in place of my c, I put 5. I know this is log 2 base 2 is 1. So 3, 1 plus 15 over 2. This is going to be minus 2 over 2 minus 5 over 2. 3 plus 15 over 2 minus 1 minus 5 over 2. So I subtract the 1 from the 3 plus 15 on 2 minus 5 on 2. This would be 2 plus, since the denominators are the same, I can have 10 over 2 down. LCM 2. 1 goes into 2, 2, 2 to 4 plus 10, 14 over 2, which is equal to 7. So the same thing here, 7. So I get 7 here, I get 7 here. So you see, this is not a difficult question, but yeah, if you don't understand how to go about it, you would feel like it's very difficult. You cannot be able to do it. Please, when you meet the questions, just take your time, relax, and then you'll be able to come out with something. Okay. Question. Okay. Question 2. Hey, that long time. Question 2. The equation of a circle is given by x squared So this is a general form of a circle, and then we have been given a particular one to work with. So with this being the case, we have to get our J and then our F, because it is the J and then the F that is going to help us get what we want to get. Without the G and the F, we'll not be able to get what we want. So if you want to find the radius, it is the square root of your G squared plus F squared also minus C, something like this here. So G squared plus F squared minus C. You don't know G, you don't know F, so we have to compare x squared, y squared. 2gx is equal to minus 4x. So 2g minus 4. G is equal to minus 2. 2f is equal to 6. F is equal to 3. I can now find my radius in this. Minus 2 squared plus 3 squared minus 12, which becomes plus 12, because the C is the minus 12 over there, so it is minus 12, that becomes plus 12. 4 plus 9 plus 12, this plus this 13 plus 12, root of 25. Root of 25 would give us 5 units. So the radius of this particular equation of a circle, the radius of this particular circle is 5 units. From the center to any part of the circle is 5 units. So let's come to the last question. The last question says that 3 to the power 2x minus 3 to the power x plus 2 is equal to 3 to the power x plus 1 minus 27. So we just have to express these ones in their simplest form so that we can just go about it. So I see this as 3 to the power x all squared minus 3 to the power x times 3 squared is equal to 3 to the power x times 3 minus 27. Okay, this would be 3 to the power x all squared. From indices, we are applying the principles of indices, and then this would be minus, this is 9, so minus 9 3 to the power x. Then this would also be 3 to the power x minus 27. I can bring this here so that I get a simplified version. So 3x all power 2 minus 9 3x minus 3x plus 27 is equal to 0. So this becomes like 3 to the power x minus 12 plus 27 is equal to 0. Now I can replace 3 to the power x with any variable. So if I decide to replace 3 to the power x with n, I now have n squared minus 12n plus 27 is equal to 0. So I look for two factors of 27 such that when I multiply, I get 27, but when I add, I get negative 12. And I see negative 9 and negative 3. The same thing here. So I have n is equal to 3 or n is equal to 9. But n is equal to 3 to the power x. If n is 3, I now have 3 to the power x. 3 to the power 1 is equal to 3 to the power x. X is equal to 1. Or this. So therefore, x is equal to 1 or 2. So this has been my Monday session of Catholic class, and then I hope you enjoyed yourself. I started with the BC preparations. If you've not watched it, go and watch it, or go and recommend to your juniors who are in JHS. I went to the core mathematics session. If you've not watched that one too, please kindly do that. Then I finally came to the elective mathematics session. So do enjoy the rest of your day. I'm out.